All right, this is section 7.2, which I don't think is actually on the screen here. So this is section 7.2, the law of cosines. All right. Now, here is the generic formula for that. All right. Now, of course, if you have different sides, of course, you'll have a different number there. It won't be c squared. It could be a squared equals b squared plus c squared minus 2ab cosine b. It could be any of those. So this is just, there's actually 3 of these. And you're going to use these. You're going to be using the law of cosines for a situation where you have side angle side or side side side. That's law of cosines. Remember, the law of sines is used for the other ones, the law of sines for all the other cases. So for the most part, the law of cosines is more work. And once you do it once, generally speaking, you'll do the law of sines to finish off the problem. I probably will not do the law of sines to finish off the problem because we've done that in previous sections and the video will go on forever. So, all right, let's give it a try here. Here's some tips. Remember the obvious, they add to 180, right? The sum of any 2 sides has got to be bigger than the third side. And then the Hinge theorem, the larger the angle, the larger the side, the smaller the angle, the smaller the side. Common sense can really help you here. Now, if you're using the law of sine, that's the S, solve for the smallest side first. What you do there is you eliminate the possibility of getting into an ambiguous case by solving for the smallest one, okay? If you're using the law of cosine, solve for the largest side first. So typically we're going to solve the largest side first, then we're going to do the smallest side and do the medium one. That's typical, okay? So let's look at the first one, 1A. Circle that, because the work will go everywhere, all right? So you got this situation. I got to draw this triangle out first. So this is my best rendition of it, just being an estimate here. So you got B is 59 degrees. 59 degrees, that's a 5. 59, that's B, okay? And then I'll extend this a little bit here. And then you got C is 3.7. So I'm going to put that one down there. Okay. And then we got A at 9.2. So I have side angle side here. I have a side, the angle in between, and then the other side. Classic case for law of cosines. Classic. Okay. So you got to set the problem and just follow it. So because you're working with angle B, it's going to be B squared, which I don't have, equals 9.2 squared plus 3.7 squared minus 2 times 9.2 times 3.7 cosine of 59 degrees. Okay, it's terrible writing, but you get the idea. Now, when you boil it down to that, you're going to end up with B equaling 7.95, which I have right here, written right there. Okay, now you got the third side, so 7.95. Okay, 7.95. All right, great. So I'm going to let you solve that by yourself on the calculator. I'm not going to go through those keystrokes. It is some order of operations, but it shouldn't be too hard. Remember, you got to square root this side at the very end to get the answer. Okay, now let me erase this part right here. Now that you have the third side, so now we have 3 sides and we got an angle. And I am going to go ahead and solve, use the law of sines. I'm going to solve for the smallest side next, the smallest. Okay? So in this case, remember the smallest angle is going to be opposite the smallest side, which is 3.7. Okay, it's pointing to that. So I'm just going to go ahead and set this thing up here. So 7.95 over the sine of 59 degrees is going to equal 3.7 over the sine of A. And again, I'm not going to go over the calculator keystrokes. You should be able to have that one down. And A is going to come out about 24 degrees. Okay, so A is about 24 degrees. Okay, and then you'll be able to get C fairly easily by going 180, of course, minus 180 minus 24 plus 59. Okay, and then that's going to come out about 97 or 98 degrees. I think it's 97 degrees. Okay, so that's going to be 97. So this is actually an obtuse triangle. Okay, it's come out that one. Had we solved for the largest side first, we would have got into an ambiguous situation because the value of sine would have produced two different angles, which is why you want to do the smallest side first. Okay, so that's A. All right. Question B. These are all going to be pretty similar here. So question B, let me circle that. Doing B. Aha, we got SSS, baby. We got three sides, SSS. Okay, so let's go ahead and try to figure this out. So for B, let me go ahead and draw it here. So what do we got here? I'm going to see if I can draw it to scale here. 4.9. I'm used to doing this, so I can estimate pretty good. 3.5, that's B. This is A. And then C is over here. I suspect this thing is obtuse. I'm not sure, but remember, I got SSS. And to review, law of cosines is for SAS and SSS. I got three sides. Now, the rule I've told you, solve for the largest side first if you're using the law of cosine. No problem. So that's going to have me solve for angle C, which is down here. Okay, so I'm going to go 6.4 squared equals 3.5 squared plus 4.9 squared minus 2 times 3.5 times 4.9 cosine C. Wow. There's a lot going on here. Okay. So let me kind of walk through this. I will not break the calculator out, but I'm still going to walk you through this. Okay. So this is 40.96. Okay. Equals, and then these two combined is 36.26. All right. And then this is minus 34.3 cosine C. Okay. Then in the end, of course, you're going to do your algebra, and C is going to come out about 98 degrees. And I thought it was obtuse. I could kind of tell. That's going to come out at 98 degrees. Okay. So back to this. You're going to go 40.96 minus this divided by negative 34.3. Okay. And then do the inverse to get the angle, which you've done in previous lessons. Okay. So now that we've got 98, I'm going to leave that there for a second. And I'm going to do some erasing. Actually, I'm just going to change color and move to a different location here. Now, this next thing I want to do is for the next angle, it won't really matter because 98 is already obtuse. But in general, using the law of sines S, solve for the smaller side first. Okay, and that's going to be this, the smaller angle right there. Okay, so I'm just going to get in that habit. And that's going to be, I'll put it up here in blue. Sine of 98 divided by 6.4 equals the sine of B over 3.5, okay? And that's going to come out about 33 degrees, okay? I have the exact answer down here at 32.8, but it's about 33. So that's 33 or so. And then go ahead and use the 180 minus rule to get that one, okay? And there you go. That's pretty simple, huh? Not bad at all. So that's the SSS case. We only got two cases here, SAS and SSS. Makes this pretty easy. And your background, well, this is why I teach the law of sines first, because you're eventually going to go back to that anyways. Okay, here's C now, okay? So on C, it looks like I got side angle side. Okay, so I'm going to go ahead and draw this as best I can. Again, I have an obtuse triangle. This is 106 degrees, and this is C, okay? And then this is 5.1, and then this is 7.7. So I have side angle side, okay? Awesome. So since I'm kind of forced to work with, I'm going to solve for C. It's the side that I need. So it's going to be C squared equals 5.1 squared plus 7.7 squared minus 2 times 5.1 times 7.7 cosine 106. Okay. Now, what's interesting is this is obviously a hybrid of the Pythagorean theorem. I didn't even cover this. You guys know the Pythagorean theorem. C squared equals A squared plus C squared. It's a hybrid of it. Now, for a 90-degree triangle, this would be, my underlined part would be cosine of 90, which is 0. So that back part's canceled out. So it's really the same formula, just kind of an add-on. Okay, now you can go through the math yourself on this, but that's going to be 10.34, okay? Now, we're going to do the smaller side first, just to be in the habit. It wouldn't matter in this case because we know they're both going to be acute, but just to be in that habit, we're going to go ahead and solve the for the smaller angle. So we're going to go the sine of 106 over 10.3 or 10.34, whichever one you want to use, equals the sine of A over 5.1, okay? And when you do that, you get about 46 degrees. If you want to look at that as 46 degrees, that might be the best way to look at it, okay? And then, of course, you can do the law of, the 180 rule. Just do the 180 rule. So I'll put that over here, 180 minus 106 plus 46, and you'll get your other angle, which is like 28. Okay, so you're only doing the law of cosines for one item, then you're going back to the law of sines. All right, so let me clear that. All right, now 1D, and again, I'm going to circle this so we can get started here. 1D. Okay, and on that one, we got, lower this just a little bit here. There we go. Do that again. Draw. All right. So 1D. Okay, don't worry about these up there. Okay, so we got an SSS situation right here. Awesome. Okay, so I'm going to try to draw it the best I can. So here's 10.8. That's the longest one. And that's A, right? And then we got 6.3. We got a little big, I think. And then we got 8.3. All right, so we got SSS. Now, please solve for the largest angle first, just in case you would get an obtuse one. You want to make sure you got this. However, I think this whole thing's acute, but we'll see. Okay, so we're going to go 10.8 squared equals 6.3 squared plus 8.3 squared minus 2 times 6.3 times 8.3 cosine A. Wow, long problem. Okay, and again, I'll walk you through this. You're going to solve this side with your calculator, 11.64. You got to get the summation of this, which is 108.58 minus 104.58 cosine A. Okay, and then from here, you'll use your algebra and you'll subtract 108.58 from 116.64 and then divide by 104.58, then take the inverse of that. I think you can handle that. So in the end, it comes out about 94 degrees. Okay, about 94. Now, I have the exact one, 94.42, but rounding to 94 is just fine. Okay, now from here, okay, we need to solve the, so this is 94. We need to solve the other ones. And I always say solve for with the sign, solve for the smallest one next. There's the smallest one right there. Okay? So let me try this different color here. So when you solve for the smallest one, you're going to go 10.8 over the sine of 94 equals 6.3 over the sine of C. Okay? And that comes out about 36 degrees. Okay, again, I kind of rounded it. Okay? And you basically solved it. And then to get the last angle right there, you're going to use the 180 rule, and that's about 50. Okay? So that's 1D. Pause the video if you need to right here to check the work. Okay, 1E. All right, let me circle that. So let me draw this out as best I can. Okay, so we got 9.7 here. That's 41 degrees. This is 7.8, so it's a little bit longer. All right, great. So I have side angle side. You can just see it. Okay, a side, the angle in the middle, and the other side. All right, so what I'm going to do, of course, is this is angle A, so I'm going to solve for side A. So A squared equals 7.8 squared plus 9.7 squared minus 2 times 9.7 times 7.8 cosine 41 degrees. Okay, now that's going to solve, A is going to be around 6.4. There's your exact answer. Okay, but around 6.4. Great. Okay, then once you do that, we want to do the law of sines next for the other parts. Okay, so we got this at 6.4. The law of sines, do the smaller side next. Okay, the next smallest side is going to be the 7.8 side right there. No problem. So I'm going to go 6.4 over the sine of 41, and that's going to equal 7.8 over the sine of C. Fantastic. Okay? And that comes out about 53 degrees. Okay? And then using the 180 rule, let me change colors again so you can spot it. I'm going to go green here on you. Using the 180 rule, so this was, where was it? Where was 50? Yeah, 53 degrees. I'm going to go 180 minus 41 plus 53. Okay? And that's going to give me about an 80, I guess an 86 degree angle right about there. Okay, so that's 86. So we've solved the triangle. All right, again, pause the video if you need to. I'm using all those skills that we talked about early on. Okay, let's review those real quick. Okay, so Remember, we've used the interior angle sum as 180. We've talked about the sum of any two sides must exceed the third side. That's item 2. Item 3, the Hinge theorem. The larger the angle, the larger the side. The smaller the angle, the smaller the side. That's so you can identify which angles to solve for first or second. If you solve for the law of sine, solve for the smallest side first. Law of cosine, solve for the largest side first. Okay? So with all that in mind, we're going to go to the last 3 problems. Let's go to 1F. You're going to like this one. Everybody likes the no solution ones. The first thing you do here is you just take a quick look at it and you realize, oh my goodness, A and C are smaller. Their sum, A and C sum is 9.5. That's smaller than 10.5. So this is not even a triangle, so it's no solution. That's an easy one. I love that one. But we talked about that, how the sum of any two sides must be greater than the third side. All right. Now, going down to the word problems, okay? We got 4 of them here. And I have the work kind of laid out for you, which is kind of nice, okay? And I'll get the drawings, the tricky part. What's kind of nice about these word problems is you don't end up you end up doing less work because you're only asking for one thing, okay? Okay, on a map, Southern California to New York. So I'm going to put Southern California right here. Here's New York, NY. Here's SoCal, all right? That's 14, all right? And there's a place in Florida is, the distance is 5 to Florida, okay? So Florida's down here. There's Florida. All right, makes a triangle there, right? If you have any sense of the U.S., that's a pretty bad drawing of that, but you get the idea. Okay, so, and the question asks, find the angle from the New York perspective. So let me get a different color so I can emphasize which angle we're talking about. We're talking about this angle right there, okay? Between the cities in Southern California. Okay, what angle is that? All right, so, you know, I don't know if you call, we'll just call it X, okay? Okay. And by the way, that's 12, right? That's 12 right here. Okay, we got SSS essentially. That's what we have. Okay, so we got a good drawing here. So when you do this, that ends up being the equation. Okay, because we need 12 to be squared because it's opposite the angle we're looking for. And that angle ends up being about 50. That's a pretty good drawing of that. 56 degree looks pretty good. Cool. All right, so that's 2A. So you need to pause that, fine. Those are actually quicker than the other problems because you're only solving for one thing. I'm not getting all the other angles or anything. All right, B. I think B is tough, okay? Due to construction, a jogger along a straight path had to take a detour, okay? At the start of the construction zone, he ran 100 feet at a slight angle away from the path, then turned 25 degrees back toward the path, and reached the end of the construction zone at 140 feet. What was the length of the construction zone? Wow. Okay, so let me try to do a drawing here, okay? So I'm going to make this 100, okay? And then there's going to be a turn here, but let me just kind of put a dotted line there. It's going to be a 25-degree turn. So this is 25 degrees, okay? And then this part is 140. So this is feet or whatever it is, okay? And then we are looking for X right there, okay? So I don't need 25 degrees, okay? I have an answer to this if somebody uses the wrong angle. I went ahead and calculated that, okay? In case you're practicing this question prior to doing it, okay? I need this angle. Well, this right here is 180, and 180 minus 25 is 155. Now, here we go. I need X, so there's my setup. Okay, again, you need to pause the video and check it out and go ahead. Okay, that is your law of cosines. And we're going to go ahead and solve for that. And if you solve it, you get this answer right there. Okay, but the drawing is the key. That's a really hard one. If you messed up and put 25 degrees there, you're going to get this answer. It's going to be wrong. Okay, I wanted to complement to 25 with the drawing. It's maybe the wording is a little strange there that I did, but that's what we got. Okay, C. Okay, question C. I'm going to make this bigger, I think. Slide it over and down. There we go. All right. So on C, as 3 baseball players are warming up, they stand in a triangular pattern and play toss. Player A tosses the ball 42 feet to player B. All right, no problem. Here's A, here's B. Boom. That's 42 feet. Okay. And then B tosses to C at 39. And I have my eye on 57 being the longest. So I kind of made that angle. Of course, I've done the problem before. Okay, great. We have an SSS deal, right? SSS, law of cosines, no problem. Now, from player C's perspective, I believe that's down here, this angle right there. What is the angle between A and B? Awesome. Okay. So here's the setup for you. Okay. Now, again, I have a little notation here because in case you did the law of sines or something like that, but you wanted to use the law of cosines here. Okay. I'm going to scratch that out because I'm hoping nobody did that. All right. So there's your equation. Okay. And this ends up being the answer. That's not too hard. Okay. Again, pause the video if you need to check that out. All right. Last one is D. D, of course, is a doozy. That's the point of the last one. This is quite a drawing we're going to have to lay out. It's going to be cool. Okay. If you want to stop the video and give this a try, that would be great. I'm going to make this real big so we can really see this. Okay. A flight tower observes that the angle of depression to a plane 510 feet away from the observation deck on the runway is 20 degrees, and another plane 900 feet away is 15 degrees. How far apart are the 2 planes? Wow. Okay, so this, again, the trick here is getting the drawing. I'm going to do a couple of them. I'll show you what I'm thinking here, okay? So I'm going to draw the most rad observation deck. Look at that thing. That seems awesome. Looks like all my other drawings. Okay, so we got this right here. And we got, this is 510 feet, right? 510, right? And this right here, I'm going to put an arrow in there, is 20 degrees. Okay? Then there is something, there's another angle right here. Okay? And by the way, they said angle of depression. Well, the angle of depression is this angle right here. If I did a straight line there, it's this one right here at 20. But because of alternate interior angles, man, it's the same as this one right here. Okay, so that one is being 20 degrees. Now, this next one is 900 feet. Okay, and then this one is 15 degrees, but that ends up being this angle as well. Okay. So I'm going to redraw the triangle that we're interested in. They want to know how far apart these planes are. The triangle they were interested, I'm going to put it on the right side here, is this one. This one's 900, okay? This is 510, okay? Okay, this is 15 degrees. 15. This right here, remember, this is 20. So that makes this one 160. Okay. All right. And then this angle right here is going to be super tiny. It's going to be 5 degrees. Okay? That's the triangle we're interested in. So I want to solve for x, this distance. There we go, x squared. You see it? Equals 510 squared plus 900 squared minus 2 times 510 times 900 cosine of 5 degrees, that angle opposite it. A lot of work to get there. And again, I have a real common mess of in case you use the law of sines, which you didn't, of course. And there's your answer. Okay? That's a tough one. That's a very difficult problem. All right. That is section 7.2 for trigonometry.